Let's start that again. We're going to go ahead. Thank you, Johnny, for letting me know that you can't hear me. That was perfect save on your behalf. We will see. This is why I got people watching my back, making sure I'm not messing up. So let's just start that over again. Welcome to Gray's Academy Intel. We have here. We're going to talk about OpenVino. It's going to be a lot of fun today. Forward-looking statement. If you need to take a look at this, please read over this, just in case we talk about some things, forward-looking. And again, my name's Dziuba, technical marketing manager focused on the industries, former automation controls engineer, Splunker for over 3 years, almost 4 years. It'll be 4 years in October. And I was a customer before that. I focus on non-traditional use cases of Splunk. First conf was in 2016, homebrewer, beekeeper, barbecuer, and fisherman. These are some of the things that I like to do on the side. And if you have questions about them, feel free to ask. We like to make this lively and fun. I'll pass it over to Johnny to do a quick intro. Johnny?
Hey, everyone. My name is Johnny Chen. I'm a Edge AI ISV account manager here at Intel. I've been with Intel for just 6 months, actually. Previous to that, I was a solutions architect at an industrial computer manufacturer. Me personally, I'm definitely a geek, an artist, and most importantly, I'm a dad. So that's my biggest job, is being the dad.
Yeah, I can relate to that. Today, like I was geeking out setting up a new printer. I mean, how can you geek out at that? I was like, oh my gosh, my phone connects to my printer and like sends them. I was like, okay, I'll send them all to my wife. She was like, okay, I'll let you have this. We'll let you have this. So, I mean, it just makes sense. That's what geeks do. So Sweepstakes. Feel free to sign up for the Sweepstakes. I think we'll be dropping that in chat as well. You can use the QR code. $25 gift card to the Splunk gift shop. So, we're a t-shirt company. So if you need to get yourself a t-shirt, feel free to check that out. In September 31st, 10 winners, 1 entry per person. Winners are announced next month. A little about Gray's Academy. Today we are doing the 301 series. But it's a 3-part series where we have the 101 series where we focus on the kind of the beginner aspects of how to use Splunk. What that means is we start digging into Splunk 101. You can follow along with me, just watch. It's just a kind of a quick little guide to say, you know what, how hard is it to get started with Splunk? And I kind of guide you through the first steps. There'll be bumps and bruises along the way just because we like to have fun with it. So just keep that in mind. And then the second Thursday, we kind of focus on some of the new features. So if you're a little bit familiar with Splunk, but you want to know about some of these new features that are coming out with Splunk, this is where you'll kind of dig in to get a better feel about those applications. And the third Thursday is kind of like the proficiency level I would describe as like expert. You're focused on, you've kind of really mastered what you've done in your role with Splunk, and then you kind of want to start thinking about some of those other areas and like maybe expanding what you want to do, and that's where you can start leveraging those third Thursdays. So we generally have it about this time for the first, second, and third. So mark it on your calendar, and feel free to join and invite your friends, especially if you know people that want to learn Splunk. It's a great way to start getting involved with Splunk. So live streaming theme, feel free to ask some questions. We like to keep it friendly. We want to tie this into that kind of .conf feel. So for the people that have been to conf in the past, when, have them in person, one of the best things that we had about it was what we called the pavilion. We could go down and start asking questions about what's going on with these new products, to get down to the engineers. And that's what we really want to bring this to as well. We want to have this type of interaction. So it's friendly, it's fun, and you start finding out some more information about what's going on in Splunk land. We do, as we go through this, you're not here to watch me play a video game sometimes for the first time. So as we bring on some products or some things, I'll be kind of going through them, and we'll have a product specialist and say, you know what, tell me what's going on with this, dig in and, kind of explore the tool, similar to, playing a video game for the first time. We do have some moderators that are going to help us out with some of the giveaways, answer some questions, maybe some reference material, for example, the giveaway and things like that, and we can drop those in as well at the end. Again, what's your favorite? Are you charcoal, propane? What's your favorite Splunk command? Mine's personally is the time chart command, because I love time series data and focusing on how that applies over time. So I got some questions out, but feel free to ask any more as we move along. So a little bit about what we're going to go over today. We did the intros. Intel's going to give a little bit of a presentation about what is OpenVino and edge uses of it. We're going to do a little bit of a demo and showing you the EII solution that we have integrated with Splunk. And then we'll be closing it out, and we'll talk about some of those use cases and how you can apply this with apply OpenVino with Splunk and really pulling that data into the environment. And I think at this point we will be going for a presentation over to Johnny. So give me 1 second as I swap that over to you. All right, Johnny, I think you're ready to go.
Yep, perfect. Hey, everyone. So I'm going to talk to you a little bit about the Intel AI ecosystem. One of the really cool tools that we have that's used in inferencing or AI inferencing quite a bit is called OpenVino. So OpenVino is really designed to make the developer's life easier. When you build a model or you bring in your own model, just by taking that model and running it through the model optimizer, you convert the model to what's called an intermediate representation. And what does that IR file really give you? It gives you the ability to basically use an OpenVino inference engine and run it on anywhere that there's an Intel processor. It's optimized to be run on Intel processors. It's optimized to use the Intel integrated GPU. It's optimized to use FPGAs, Xeons, and so forth. It accelerates the performance of your inference and your model. One of the cool things about it is the whole idea of OpenVino really is write your code once and deploy anywhere. So you could deploy to, like I said, cloud, edge, throughout the entire AI ecosystem. You could deploy it. And by having that write once scenario, you're looking at, you can use every part of the processor, from the GPU to the CPU, including some extensions, AI accelerators, and FPGAs. And Intel goes far beyond just processors for AI and inference at the edge. We have technologies that enable and drive the entire AI pipeline, from processing power to network technologies to highly reliable storage. Intel is really here to support the entire life cycle and the lifespan of AI from beginning to end. So OpenVino, like I said, it's all about optimization. And this is where I kind of want to show you guys how much optimization could be done just through OpenVino. Without OpenVino, when just using CPU only, you could achieve one stream at about 28 to 30 frames per second. When you use the same hardware and use OpenVino to optimize, you can run the inference on both the CPU and the GPU. It allows you to stream up to 16 streams while keeping the same performance. To further increase the performance, we use the same hardware and add a Movidius accelerator. Now you're using CPU plus GPU plus the accelerator. You can achieve up to 49 streams while keeping the same high frame rate. To kind of wrap up OpenVino is all about the AI developer. It was designed to optimize models to maximize the performance on hardware. It streamlines your development process and is designed that you write once and deploy anywhere from cloud to the far edge. High performance, it's about converting and optimizing a model to achieve the highest performance for deep learning inference applications. Streamline that development, right? Facilitate a smoother development process using the included inference tools and low precision optimization, media processing, computer vision libraries, and pre-optimized kernel. The whole idea of this, write once, deploy anywhere. Think about deploy the same application across a combination of host processors, accelerators, and environments, including CPUs, GPUs, VPUs, FPGAs. And this could all be done on-premise or in the cloud. Another key building block or a cool tool that we're going to talk about is called Intel Edge Insights for Industrial. It is a reference software ready for customers to customize for their specific application. It's designed with a microservice style design to enable the developer to pick what do they want in the stack and what don't they want. It has a built-in time series database as well as video pipeline to move and manage the data from app to app and from edge to the cloud. It's built on open source and fully modular, and Intel provides a large catalog of reference implementations for specific industry uses. Think of Edge Insights as a toolbox ready to help you build your edge platform. And what's also inside the toolbox, of course, is the OpenVino element for AI inferencing. In closing, I kind of want to share a project we did with Audi. Using our Edge Insights software, as well as OpenVino, we created something really special together.
Take new technologies and figure out will they help us in
revolutionizing our production, becoming more efficient, becoming better in what we're doing, building cars.
Through our work with partners like Audi, we've learned the value of the capabilities that we've had for years in the IT space to bring those into this operating technology world. The ability to virtualize workloads and move them where they need to happen.
Our joint Spotweld case together with Intel was a great first start. Intel helped us in looking into the data, identifying how to get access to the data, how to label the data, and which kind of data we would need.
What we've learned is there is a need for increased levels of edge compute to analyze at the site where the flow of production is happening in order to take action there. Intel has worked with partners and customers to help solve those challenges close to where goods are produced.
How can we get our production lines running at higher efficiencies than we have them running today? We have to look and think out of the box in order to take these steps towards the future. This is the value we want to tap with this entire infrastructure we have been setting up with Intel.
And that's it. But if you really think about it, what do you do with all this data now that's coming in, right? And this is kind of where our work with Splunk really happens is, beyond capturing at the edge and analyzing at the edge, now we want to take all this data and make it a part of the business intelligence. Right now, it's at the edge. It creates value for the operational side of the enterprise. So how do we take this data and how do we make it valuable for the entire enterprise?
Perfect. That was wonderful. I'm gonna go ahead and stop sharing your screen real quick. I mean, that's exactly how I kind of imagine. For example, in the Audi example, you're looking at an instance where you're creating a lot of edge design and information, and then being able to take that data and then correlate it across other systems. So, for example, I always think about it from like a quality standpoint of a product being made down the line, and you want to know what the parameters were made and when that could have happened, and then bringing them back to a single point of interest. Because, like, for example, a vehicle, you've got the vehicle made multiple different things down the line, and it's almost like a time series application, and seeing that quality in real time and being able to bring that into a single system, just it's absolutely exciting to me to think about it, and especially bridging that different case. And that's just applying it to the manufacturing application. So we'll take a pause, and what we'll do is I'm going to show a little bit of a demo of what we've kind of been working on real quick. So what we're seeing here is an OpenVino application running, which was one of the kind of the sample data sets that the Edge Insights for manufacturing supplies. And then what we've done is we've created a ingestion ability from that inferencing system, and then ported that into Splunk. So what you can see here is the demo that was created that I think we can probably link in the chat here in a little bit. I think I've got it. But you can see it's running images, storing them, and then running the analytics on it. And then very simply, the next thing we've done is now taken all the data. So let's say, for example, the image information, all the metadata, all the exhaust associated with that, and then we drop that into Splunk. So it's one of the things that I super get excited about, is because, when you start bridging that physical virtual world and taking that image information, applying the machine learning, then taking that metadata, you can then start filtering it down. So what I'll do now is I'll show you now a screen, if I can get it going real quick. Just give me 1 second, gotta switch screens. And double check. There we go. So this is a very, very, very simplistic dashboard that I've kind of created. And it's really, of course, I mean, if you're a Splunker, you're like, I'm seeing the value behind it. But I mean, as you kind of see this, what we're getting is, let's say, the image number of detected images. We've got the total number of defects in the time range. For example, I've got the time range picker. Just kind of, let's say, for example, I want to drop it for the last 60 minutes. Kind of doing those calculations behind the scene. And then what we've also done is I've got the images here below that I can point to where those images exist. So, for example, I want to make a filter, a Splunk search that says, okay, give me all the off quality that has to do with this particular issue. So if you kind of think about it, you're saying, hey, you know what? I want to look at all of I think there's like a example, like a tombstone of like, let's say a circuitry that wasn't necessarily soldered correctly, and it kind of like pops up. And you want to say, hey, I want to see all the ones that are happening in this quadrant. And if you build your inferencing, you can then define that. So you can use Splunk to say, okay, give me all these specific circuit boards, give me all these tombstones, and then you filter it down to a certain time period. And then you want to say, you know what, I want to correlate that to my manufacturing system to think about like, well, what solder was I using? What was the source of that solder? Where did that come from? And then you start digging in, and you can say, because a lot of the times when you start having like, especially manufacturing chargebacks and things like that, you need to be able to have the data to prove that the issue was with this. And this with like Splunk, you can start correlating that information very quickly and easily. So I kind of paused there. I kind of just really jumped and got really excited. So I want to see what Johnny's thoughts are on this and see what, like, as he kind of sees this progress in his kind of viewpoints.
No, I definitely see your point, Gray, and see the huge value. I work with customers all across different industries, right? But all in the AI ISV, independent software vendors, and how it's being used, the software itself, as well as the inferencing. What's interesting is, this whole idea of bridging the gap from, what they call OT or operational technology to IT to full enterprise, that there used to be a real firewall there. The two were very separate. But I think today with technologies like this and with Splunk, being able to ingest, image data now and being able to take the metadata and then put it as part of the business intelligence, you're seeing that firewall go away. And what you're getting is more and more value, right? You now have full traceability of not just your front office, but your back office, of everything that happens, everything that's built. And like you said, you could actually go back, and there are companies out there today that have very strict requirements for quality. So on the automotive side, especially on the EV vehicles today, they actually require that you basically have a video archive of the battery. Every single battery needs to have its lifespan recorded from the beginning of manufacturing, from the chemical process all the way to the pack out. And that record is kept for several reasons. It's to reassure quality, or if something happens in the field, because EV is so new. By having systems like this and being, like you said, time series data and having metadata, you no longer need as much storage or as much space to hold all those things, because now you've created something much more portable, much more analytical, and much easier to trace. That's one of the key things I see, especially in manufacturing, is how do you create so much data for it?
And since you're, especially in cases like that where you already have the requirement to have the data, might as well use the information as is. And that's what you see a lot is like, hey, you've got the data, might as well use it and start digging in. And and there's some other use cases, but before we start jumping into use cases, because I definitely want to kind of do a little bit of playing around with some of the splunking. So I'm going to bust up one of these searches and really kind of talk about a little bit. So I'm going to take a really simple Splunk search here. Everybody's familiar with stats or Splunk stats, the stats command inside of the Splunk searches. So don't think that there's any super impressive stuff. It's just simple metadata coming in that we're pulling in. So we've got last 60 minutes. I'm going to drop off the stats command and just kind of show you what we've kind of pulled in. Again, I apologize. I'm like looking up at the screen here, but in this particular case, we're looking at, the additional information and metadata that's like the digital exhaust coming from these environments and associated geographical referencing and things like that. So you kind of start digging in, and this is all dependent on the model that is being created and trained inside of the OpenVino toolkit. And one of the things that I always like to highlight here is we're starting to break that mold. And because I was, background in manufacturing, and anytime we had any type of image inferencing, whether it was like measuring how far away something was, or whether that was within the GD&T, geometric dimensioning and tolerancing. Yep, I got that one right. And you start thinking about that, like those are all little black boxes that are sitting on those spaces. You can sometimes be leveraging, let's say, like a Cognex or some of these other, smart cameras that do it all on board. But the thing is with this, you start really valuing all that raw data as it kind of comes into the environment, and you can see and pull, and you just kind of open it up the world to then dig in even further. So as a developer and start, digging into this, you're not seeing my screen. My bad. I got excited there for a second. Somebody's dropping me a message. See, this is why I got people pinging me. Let me fix that real quick. Chrome. So as we kind of see that come through, I forgot, lost my train of thought, but basically they're no longer black boxes anymore. And that's like one of the biggest values as you start thinking about it is it's just not a black box as far as like digging in. And now you can manipulate, you can start doing things and kind of self-servicing it to some extent as you go across this. And I realize I'm not sharing my screen again, but I've got it now. All right, we're there. But so you can simply look at this. You've got all the additional metadata information and define it. And, there's multiple different ways of analyzing images. I don't know if, Johnny, you want to kind of talk about that, like whether or not you're saying, like, is this, good part, bad part? You got the Boolean applications. Then you have specific, kind of diving in and really just depending on how that model's broken out is really how that data is coming in. Thank you, everyone in chat, for making sure I'm staying on online with that. But just kind of wanted to point that out.
Yeah, and what's exciting about getting all this image and all this data is, the key thing here is actually to prevent the problem from happening in the first place, right? The whole idea is, you see trends. When you see a trend, you could dig deeper. And after a while, you could build in that intelligence to know, I'm starting to see this trend. This is what's happening. And now you have a way to basically stop the issue from even happening in the first place. And that's one of the key things, in manufacturing. I came from the industrial world, and manufacturers are always, the biggest key to manufacturing is efficiency. And how do you get efficiency? Stopping problems before it happens. And this is exactly what these type of tools really bring to the table.
Yeah, no, absolutely. I actually worked on a project very similar to what you described in one of my former roles. Was basically we had to make a product that was on a continuous product line. And we took the parameters associated just to where if I press start button in a mile and a half, will the product be good? Based off just the initial, what are we going to be within the tolerances or close to it? Are we close? And really just kind of doing that projection, even just kind of start using some of those fundamental machine learning capabilities to get you started down that path. So we got something in chat. Yeah, we do plan on sharing that information. I do have that in the presentation, and I will drop that link here shortly. Let me see if I can actually just drop it real quick for you. Since you're there, I don't want to lose you. So there's the Intel reference, and I'll have to drop them over into the LinkedIn real quick as well. So let me just drop that real quick. And then what we'll do is we'll kind of take it on to the next part of the call. And we've gone through the demo. Really, I didn't want to highlight too much about I don't want to go through how to use a search command, because I expect a lot of people that are familiar with Splunk to really understand, how the Splunk process works. And just really kind of want to open up to thinking about what are the applications, and that's really where I want to go next. So let me go ahead and share that. So I made a quick little screen, and we've talked about manufacturing quality, and to me, that's from our backgrounds, it sounds like the most obvious use of something like this. But one of my next favorite points, especially for all those Splunkers out there, is the bridging of physical security with cyber security. So I know I've probably given this example a couple of times, But think about it as if, you've got all the tailgating, conundrum that people always like to talk about all the time. One badge reader, 3 people go in. That's a big no-no. So think about it as if you can measure 3 people at the front of the door, and then within a certain time period, leveraging Splunk and that physical access, you say, okay, I see 3 people going in through a door, physical badge reader, and now you can say, hey, you know what, alert, this seems interesting, fire off whatever playbook you want, whether it be whatever mechanisms of Splunk. But from your side, Johnny, what are some applications that you can think of that maybe kind of bridge that physical and cybersecurity, or have you thought of other cases?
Well, definitely, physical and cybersecurity is really interesting, especially when it comes to vision AI. It's actually used quite a bit in retail space. Everything from theft or loss prevention, but beyond that, the AI is actually getting smart enough in which it can start looking at suspicious behavior. If you look at someone that is pacing back and forth or always lingering to the same spot, you start noticing this person checking out a place. Things like that. AI is getting smart enough where it can start being a little suspicious of the person and actually notify security, say, hey, you might want to go check this out. Someone looks like they're scoping out, the place, or scoping out a car or anything like that. And we're seeing that used more and more everywhere from, what you think of, stores and malls, but even into car dealerships. Even car dealerships are implementing these type of technologies. And at the end of the day, right, it's all data, but how do you make sense of all the data, and where do you see the trends? The big part is seeing the trends and understanding what to do with it. So I think that's a big thing we're starting to see more and more, physical security.
Yeah, and that makes sense. And that kind of even ties into the next one, which is public safety. The person going back and forth, seeming suspicious, somebody that's you haven't seen, like they show up, and you start pulling in these public safety type of applications. And Julie, I kind of started thinking about like campus safety type of like, where's everybody, you've got a big event, let's say a football game or something like that, and you just see some people suspiciously where you've never seen anybody during a football game during this one area before, and it just kind of throws off those red flags. And you can start saying, well, do I have any cybersecurity information going on at the same time? Do I need to just see what's going on? And then you can just correlate them all together into a single solution. And I like that one a lot, especially with, let's say, public safety. As far as, let's say, somebody hits a help button on a button in an environment, and then you have like let's say, campus safety sends off a message, and you can just correlate those together quickly. And then the last one I just kind of threw up here because my wife's in healthcare. I always think about the aspect of how can you apply this to, let's say, maybe healthcare. And of course, the easiest one for me has come up like X-rays or something like that. But there's probably other cases in which you can apply it as healthcare as well.
Yeah, healthcare is super exciting right now, especially in AI, because it's interesting because if you look at a doctor that's looking at an MRI or looking at doing a cancer diagnosis, for instance, they have years of experience looking at those images and figuring out if you have cancer. But machine vision has a lot more data behind it. And usually the machines today that are being built, there's building AI into it to help the doctors find it faster. Mm-hmm. Literally, machines can find anomalies, things like that faster. So I work with a lot of companies. That's what they focus on, is that software vision to basically go through, 3D images of the human body and find the where they think there's cancer. And literally, this is now could be done in minutes versus hours of a doctor combing through the images and then finding where he sees something wrong. Yeah. So healthcare is a huge area growth.
Yeah, and I can see, I know enough of HIPAA compliance and understanding from my wife and her dealing within the healthcare industry and all the associated legal. But I know that Splunk does do a lot of work in there to make sure that we are compliant to some application. So it'd be very interesting to see how that would be used in the healthcare industry. And as you think about it, I can't remember the specific physician type of that looks at X-rays and things like that. But I mean, a lot of the times, I'm sure, I don't know the process, but I imagine they get an X-ray with the expectation of looking for something. So then, there's going to be sometimes, and there might be cases where people have other issues that may not necessarily be obvious unless that physician is specifically looking for that. And if you can run all this data and say, hey, by the way, I know we are looking for like a dislocated shoulder, but you also have a mass here that you might want to have checked out. I'm not that type of, but it's, for further diagnosis to be addressed by a doctor, as I think my wife likes to reference, to be further, coincide with another type of evaluation. So that's really, really interesting use cases.
The interesting thing is you mentioned about HIPAA. That is a huge deal if you think about, the amount of data you have to analyze at the edge, and then, what do you send back into the cloud, right, or into a public cloud, and how do you correlate all the data together and still be HIPAA compliant? If you look at traditionally and this is the interesting part, traditionally these machine makers that are building these AI systems, they do everything as much as possible internal in terms of on-prem in hospitals. But as you start turning into metadata, you turn it into things that would be HIPAA compliant to release, that actually generates more value in the long run, right? Because now you can create even larger database to look for things. I think that to me is I think the partnership with Splunk is really interesting, in that area, is because you're now taking what we do at the edge and make it valuable and create more value out of the data when you combine it all together.
Right. And so we're about to get into that like forward-looking statement type of thing. So I'll just remind everybody we had a forward-looking statement. So as you think about it, so let's say, for example, and kind of switching back gears over to, let's say, manufacturing quality. And so then you have the inference that says, hey, I'm seeing this is bad quality. And then you can apply that to your overall, let's say, machine learning, like master, whether it be Splunk or some other solution, and then you can push that all back down to the edge, and then you can then apply that. So you go from your machine learning on the edge back to the cloud to say, or it can either be done there and sent directly to the machine to do, let's say, some kind of change. But if it's something a little bit longer or larger than what that little, let's say, edge device can capture and respond to, then it goes to let's say the cloud, and then comes back down and says, hey, by the way, down the line, I need to change my feed rate or some other parameter to adjust. And then you can then time it to say, okay, based off of when I sent that, as the product is going down the line, and then you can see that change in real time from your AI to see if those changes are affecting in a positive manner. Of course, because everybody goes into the manufacturing environment, the favorite thing to do is, it's down, start turning knobs and see what's going on. And then nobody knows what actually fixed the problem. And then you find out somebody just turned it off and turned it back on again. So
that is so true. That is I think the first troubleshooting thing everyone does. Just turn it off, turn it back on. And you're absolutely right. Manufacturing quality is interesting is because if you think about it, computer vision is much more powerful than human vision because human vision is objective. And if you look at, how these manufacturing systems actually work, they don't just use optical. A lot of times there's, infrared, there's, multiple cameras. And be able to see things that the human eye can never see, and that's the beauty of it. It's faster, it's more efficient, and it generates, so much value. Exactly what you said is prevent the problem before it even happens. You can adjust the process as the manufacturing goes, and some components require that from the get-go.
Oh yeah, I mean, you're because the thing is everything an example I've looked at here is human readable images. But I say human readable, every image is readable. But what I mean is when you start getting into that, let's say, laser scanner as a product is going down the line to look for defects or cracks or imperfections that would cause some stress issue, then you can then do that in real time.
Yeah.
And that's something that is a little bit harder to read as a human to understand what you look for. You can, of course, be trained for that. But if you're looking for multiple different defects, you got to constantly be paying attention to that. And that's a very, very difficult thing, especially when you understand what off quality can cost you. I know, let's say, for example, in a manufacturing environment, or especially auto manufacturing, you need to know what number of cars that may have potential issues, what type of level, the severity, and that's just a whole different thing. And then in my previous industry, which was a lot of textiles, you have things where quality shifts slowly. It's not some big, like, it's good and bad. It's kind of good. And then, then you buy, let's say, especially in tile, that's one of the things when you go and buy tile, you generally go and buy tile from the same batch. You make sure you order enough, because no matter what company it comes from, it changes from time to time. Same with like a lot of things. So those claims kind of come into play, and eventually people are going to buy from two different batches. And if you start making sure that your batches are more consistent, then it becomes a thing of the past.
Well, automotive is interesting, as you mentioned, because automotive in the past, a lot of times, they do what's called destructive testing. So if you think about, they'll build a batch of 100 products, and they'll take one, and then they do a destructive testing. If they find out that one part is bad, they throw away the whole 100 that they built.
Yeah.
And you do another batch.
Yeah, this is part of the lean manufacturing Six Sigma process where, based off of it, you test one, and the probability of you getting that one that's bad. But if you do get that one that's bad, that's probably it makes my head spin. I'm in software now, maybe because of some of those things. I'm like, oh. But yeah, no, it's wonderful. What the OpenVino product and how this kind of all ties together, and as we start bridging those two spaces, so I really appreciate it. I don't know if there's anything that you want to kind of add to. If not, we'll probably look for questions and start closing out. Yeah.
No, I think Intel is super excited in this space. I mean, we've done a lot of inroads. Especially into from the physical to the digital world, especially in the edge AI side and all these industries. And we're excited just because it's getting faster and faster. And it's interesting because in some ways COVID accelerated, this process. More and more people, want to get, have these type of applications because it improves the quality of life for everyone and improves the quality of product.
Yeah, and every manufacturing facility is trying to get to that beautiful solution, which is the lights out facility. And to get to that point, that's what people are looking at, is getting there. So, and this is one critical point of it. Let's see a couple of other things. I did drop these two links in chat. Again, we do have some partners that are focused on getting these things up and running. Reach out to your rep, or if you're a partner interested in learning more, ping me on LinkedIn, and we'll get you lined up or pinged, and we'll make sure that we put you in the right contacts to get moving forward. But if you're a customer and want to find out more information about this, one of the links is to the blog that we wrote about. And then I also linked the Intel solution for the EII and kind of what we saw as far as a demo today. So if you want to start there and kind of work your way backwards, feel free to do so. And then Grey's Academy survey 301. Punny, that's the first time that I made that slip on that punny reference. There is a survey here. I do believe I had it, but I don't think if I could potentially get one of the mods to potentially drop that in chat. If not, you can do it from your phone and just scan the QR code. I'll leave it up for a few more seconds. And this helps if you like what you saw today, you say, hey, you know what? I want to dig in more on a specific application. This is where you want to start putting those requests. Say, hey, I want to know more about how we guys are, let's say, using augmented reality. How could we then drive this? And that can kind of give us some directions that maybe Johnny and I can start working together and kind of building some next steps for you guys. So please feel free to fill this out. I'd appreciate it if you'd fill this out. And last but not least, Conf, Splunk, 2021. Sorry, my brain just hurt real quick. Is it really 2021? October 18th through 21st, we are hybrid and we are virtual. So please sign up. One thing to note, there will be another presentation going over what we have discussed today. It won't necessarily be the exact same that we did today. It'll actually be different. I know we have some of our partners on there presenting in addition to Intel. So if you want to know more, you want to start asking questions there, know that you can reference this as well to some of your colleagues to find out more information. And thank you all for coming and joining us today. So we will wait for a few more minutes just to see if we get any more questions coming through. If not, we will close out. Johnny, you're going to be, we'll get you up on stage at Conf. I don't think you're going to be up on this one, but we'll get you up on stage. You know, you got to we'll do another breakout. The session hasn't been defined about when, and that's what they're called, is breakout sessions. They haven't been defined just yet, but keep an eye out for that because I would have linked exactly to that specific breakout session. But if not,
I don't know, it's going to be exciting. I think Conf this year is going to be exciting because I think everyone's finally getting back to being able to travel, and everyone's going to. I'll be honest with you. The funny thing is, I kind of miss hotel rooms, which is kind of funny.
Yeah. There's something about that every once in a while you're just like a hotel room. But I think, Johnny, it is what it is. I miss them at times. That I'm just so happy to be at home at times as well. So,
yeah.
All right. Well, thank you so much for joining me today, and thank you everyone for following the stream today, and thank you so much.
All right. Thanks, everyone.